So in this video we want to take a look at how we can connect DMX to our KNX system, and this with the help of the Weinzierl KNX DMX Gateway 544. Now, before we dive into the EDS and parameterize the gateway, let us first of all take a look at some fundamentals about the DMX protocol. First of all, DMX stands for Digital Multiplex. But what is DMX? Well, DMX is a control standard used for lighting control, effects, etc. So DMX is commonly used within the event industry in the stage technology and is used there to control the stage lighting, effects, etc. And because of that, you have a wide range of different lights that you can use, and therefore it's really interesting to use DMX inside your building. And this is where the Weinzierl KNX DMX Gateway comes into place. But how is DMX structured? Well, pretty straightforward. Here we can see a little example. We have a DMX control panel with some sliders and buttons, and this is then connected to the different stage lights in a bus topology or in a daisy chain. That means that from the control panel a connection is made to the first stage light, from the first stage light to the second, etc. So every DMX light, or most of the DMX lights that you can use, have two DMX ports, one in port and one out port, to daisy chain those lights together. And now instead of the control panel, here you can use the KNX DMX Gateway 544 to connect this DMX line to your KNX system. And by doing that, you are then able to control those lights with your KNX touch panels, push buttons, automations, and so on and so forth. So the DMX Gateway by Weinzierl can be used as a master device, so to send telegrams onto the DMX bus, so to control those lights. But it can also be used as a slave device. So what you could also do is that you can hook up the DMX control panel, and then with the DMX control panel you can also control, for example, KNX lights. So in this case the DMX gateway acts as a slave. So this is how a DMX system can look like. Now let us take a closer look at the DMX cable. Here we can see that a DMX cable consists of at least two wires for the communication, so plus and minus, then an additional ground. And this is also surrounded by a shield because of the high transmission rate DMX uses. So this is the DMX cable, and to connect the cable to the lights, normally XLR plugs are used. So those XLR plugs then have 3 pins for the connection. Sometimes also 5 pins are used. Then you have 2 additional pins or 2 additional wires for additional communication, bus communication, etc. Now here in the case of the Weinzierl gateway, you only need the plus and minus connection to the gateway, then you connect the shield to it and an additional 24-volt power supply, which we will shortly see. So that's the physical structure of a DMX network. But how does it now work? Well, that's pretty straightforward. In DMX we have up to 512 addresses, and each address has a data length of 1 byte. So DMX only knows the value 1 byte, so 0 to 100% or 0 to 255 in decimal values. And that's basically all we need to know. Now besides that, obviously the devices have to be addressed, or the data points of the device have to be addressed to one of those 512 addresses. And this is where the manual comes into place, which is really important to have it in DMX. So here we can see a little example with the DMX lighting spot, and if we take a look into the manual we can see that it has a 3-channel mode, and in this 3-channel mode the light here uses 3 addresses, 1, 2 and 3 for the RGB values, so that's pretty straightforward. Besides that, the device here also supports a 5-channel mode. And in this 5-channel mode we can see that we have 2 additional addresses, the addresses 4 and 5. And in this case the address 4 is used for the dimming value itself. And then the address 5 is sort of a special case, because here you can see that different values are for different effects, let's say it this way. So here we can see that the value 0 and 6 to 10 means that the light is simply being turned on, while the values 1 to 5 are for music control, so that's an, let's say, internal effect this specific light supports. And then you can see the addresses 11 to 255 support a strobe mode internally by the DMX light itself. Now, okay, here we see the different data points or the different, let's say, channels, each with their own address. But how can we address the device now? Because if we take a look at the manual, it simply states 1, 2, 3 and 1, 2, 3, 4, 5. Well, normally if you have such a DMX light, you address it either via dip switches, or on the back of the device you sometimes also have a little display where you can set up those addresses. Because what you need to know is that the addresses that are stated in the manual are more like an offset. So that means that if I turn this light or set this light onto the address 1, so normally you only define the starting address, here in this case now the starting address is 1, well then we can use the addresses like it was stated in the manual. So the address 1 means red, 2 green, 3 blue, and in the 5 channel mode 4 is for the dimming value and 5 for the effects. Now if I go ahead and change it, for example, to the starting address 10, then remember it only was sort of an offset, so then the address 10 means red, 11 green, 12 blue, 13 for the dimming value and 14 for the effects. And if I go ahead and change it now, for example, to 16, then the address 16 is the first address, so is for red, 17 green, 18 blue, and so on and so forth. So the addresses that are stated in the manual are only an offset to the starting address that you define in the device, either via the display or with dip switches. And there I want to get to another specific case that we have in DMX, because what's, let's say, it atypical to other bus systems is that in DMX address can be used by multiple devices, and with that we can sort of group DMX lights together. So here you can see we have 4 DMX lighting spots. The first 2 are addressed to the address 1, 2, 3, now here only in the 3 channel mode for simplicity. Then we have the third lighting spot on the address 10, 11 and 12, and the last one on 20, 21 and 22. Now if the DMX gateway now sends a telegram at the address 1 with the value 100%, we can see that the first 2 lighting spots turn their red LEDs on to 100%. Now if the DMX gateway goes ahead and sends a value 100% to the address 21, we can see now the last spot turns its green LEDs on to 100%. Yeah, and that's basically all we need to know about DMX. Now let's take a look at the hardware of our KNX DMX Gateway. So here you can see the KNX DMX Gateway 544. You can see it's pretty small, only 1 module in total width. And we can see that on the top we have the KNX connection, and on the bottom we have 2 terminal connections. The bottom is for the connection to our DMX line. So here we can see the data connection and also the ground. And the top terminal is then being used for the additional 24 volt power supply. And here it's really important that you use a separate 24 volt power supply and not the secondary output of a KNX power supply, because this secondary output isn't galvanically isolated and normally also has 30 volts. So this is something that you have to bear in mind. And besides that, we can see that on the top of the device we have 2 push buttons, which are pretty important, because with those we can first of all set the device into programming mode, but we can also use it for manual control, and this is really a handy feature after you have installed the device, because with that you can easily check if your installation is correct. So what I would do is that after I have installed all the devices and I have powered it up, before I even start to program the device, I would use the manual control to check my system if I have connected everything correctly. So that means that I press the all button long. Now you can see the mode LED changes. So with that we are now in manual control, and send broadcast telegrams, so to every address on the DMX device. And now those two buttons can be used like for typical dimming in KNX. That means with a short button press on the upper button, we turn every address to 100%. With a short button press on the lower button to 0%. And with long button presses on the upper or the lower button, we can dim the addresses up or down. And so with that, we can easily see if all connected DMX lights react to those telegrams. And only if I have done this, I would start to go ahead into the EDS, which we will do now. So I'm now here in the EDS in my project and have already added the KNX DMX Gateway 544. So let's jump directly into the parameters. First of all, here we can see a little description, some general settings that we can set up here, and then directly we head into the DMX settings. And in here we basically first of all tell the device whether it's used as a DMX master device, so to send DMX telegrams, which is when we want to control DMX lights via our KNX system, or if we want to use it as a slave, so if it should get DMX telegrams by, for example, a control panel and convert it to KNX. So first of all, I want to use it as a DMX master. And then we can set up the different channels that we can use. And basically there are two different kinds of channels beside the sequencer, which I will come to shortly. So first of all, we have the dimmer channel. That is basically just a 0 to 100% value that can be sent onto the DMX bus to one or multiple addresses at the same time. And then we have RGB channels that are basically 3 addresses combined to one RGB object. Because we saw DMX itself only knows those 1 to 100% values, and with this RGB channel, the gateway itself is decoding the RGB value into the 3 different percentages for red, green and blue. So in my case here I have a spotlight in 5-channel mode, so with RGB and their own address, and then the dimming value and some effects. And so therefore I need 2 0 to 100% values, and I have 1 RGB channel. To the sequencer we will come shortly. Then we have some additional settings regarding the DMX communication, and we can also enable a diagnostic object. But let us now directly hop into those channels that we just set up. So let us first of all take a look into the RGB channel. So each channel we can give its own name, so here I will call it Spotlight RGB. Then we can specify if we want to also get the state, so a feedback object, and when this should be sent. So I'll simply send it to on change. And then down below here we can enable which feedback we need. In my case I want the on-off feedback and the RGB color. Down below here we can enable some additional functionalities like scene functions. We can have different objects or separate object for each color. For saturation and brightness, this is just regarding the KNX group objects. And then down below here comes the interesting part where we need to set up our DMX addresses. Now in my case I have set up the lighting spot to the starting address 1. And we already saw it in the example. So in my case, I have the address red on 1, green on 2 and blue on 3. And here you can see also with some examples, we can add multiple addresses to one KNX group object. So we can also group those DMX lights within here. So here we can specify multiple DMX addresses that should be included in this channel. And we can also exclude certain addresses. Here in my case, I only have those 3 addresses. And with that, I basically have already set up this RGB channel. So if I take a look into the group objects, here we can see that we have a set value object and 2 state object. That's basically it for the RGB value. And for example, here for this set value object, we can also specify a fade time if we want it. So that's first of all the RGB channel. Now let us head over to the dimming channel, and here I also first of all give it a name, so spotlight and then dimming. And in here we have basically, first of all, the same setup. We have to specify if we want a state object, which I want. And then down below here we can also first of all specify the DMX channels that should be included and also some excluded addresses. Here in my case I only want the address 4. And with that we have the dimming channel already configured, but you can see that here we have a second window for some settings, and here we basically can specify which group objects we need in KNX. So do we need an on-off object, so a 1-bit object, and how should it behave? Here we have it for the relative dimming, so long button press, like for example you have it on a push button. And here we have it for the absolute value. So here we can specify minimum and maximum values and also the fade times. And here down below we have the object RGB value. This just means that we could also have an RGB object for this dimmer. And if we enable it, we can then specify to which color it should react to. So if I set it to, it should react to the red part, it will calculate by the color that was sent to this object on how many % red should be on, and then it will send this percentage to this DMX address that we specified here. So that's really some special use case, because normally you can use here those RGB channels instead. So that's for my dimming function. And then I had the 5th address that was used for some special effects, like for example strobe effects. And here I want to use this dimmer therefore. So spotlight effects. And in here I specify the address that should be included. So address 5 is it in this case. And then for the dimmer, now here in this case, I only want to send absolute values, because we saw for this 5th channel, these absolute values mean different effects that are enabled. So therefore I don't need an on-off object. I also don't need a relative dimming object. I only need the absolute object where I can send the specific value onto it. And now here you have to bear in mind that this gateway expects a value from 0 to 100%. 100% means the value 255. So here you have to do some manual calculations to know which value you have to send for which effect. That's also based on the device that you are using. But what I would also do is that I would disable this fade time, so that when I want to activate an effect, it's directly activated and it's not dimming to this value. So with that being set up, we can see all the group objects that we have. So we have here our RGB objects, then we have our dimming objects, so on-off for relative dimming, absolute dimming, and also the state. And here we have the absolute object for my effects, where I also want to enable a state object. With that being set up, I would say I hook it up to some group addresses and download everything onto the device. Now, as mentioned, the programming mode on the device can be enabled either by pressing both buttons at the front at the same time, or by using the small button behind the cover of the switching cabinet. So now I have downloaded everything onto the device, and therefore let us send some values via the EDS. So first of all, I send the dimming value here to 100%. So 100%, and then what we should see is that we also get a response here. Here you can see now 36%, 100%, etc. So here it now took a time, because here we had set up a fade rate, which we can see here in the parameters. If I take a look into the dimmer and to the absolute object, here we have a fade rate of 4 seconds set up. Now here it states that the light is at 100%, but if we take a look at it, it is dark. And that's the case because I haven't set up a color where the spot should turn on to. So therefore, let me quickly set the color here. For example, at the value red. I click on OK, and now we can see that the light goes on the value red. Now we can also go ahead and change the dimming value. So for example, to 20%. Now you can see that the light is darker, and we can also see it here in the feedback object. And now let me change the color. So for example, let's go here to such a color here with a little bit of green and blue. And so what we can see is that the color changes. So everything just works fine. Now what I can also do is with the on-off object here, I can turn the light off and I can also turn the light on. And now here in this case, we can see that the dimming value is now at 100%. And that's also something that we can change within the parameters, because in here we can set it up at the on-off object that it should either go to a fixed value when on telegram is being sent to it, or we can say that it should go to the last dimming value it was set to when it was turned off. So then in this case it would have turned to the value 20%. Yeah, but that's basically working just fine. Now the last thing that is missing are the effects. And now here in my case I want to turn on the strobe effect, and here it's pretty easy because the strobe effect is, for example, the value 255, which is just 100%. So here you have to convert those 0 to 100% into the value 0 to 255 to send the correct value. Or what you can also do is that you change the properties here to the value 8-bit unsigned, and now in here you don't send the decoded value into percentage, but really the binary value, so 255. And now I can see here in my case the strobe effect is working just fine. So if I go back here to the value 0, we can see that the light just goes to 100%. So that's working just as intended, so I could hook it up now to KNX touch displays or push button sensors, etc. Now one thing that is still missing that we want to take a look at is the sequencers that I can activate. So I can go in here to the DMX settings and activate such sequencer channels. So, and inside of this sequencer we can now create our own effects. Now what we can't do is, for example, create strobe effects, because therefore, KNX is simply too slow. But what we can do is, for example, create sort of a color loop. And this is what I want to create now. So first of all, I go ahead and activate 3 steps which I want to have in my sequence. And for each step I can set up a different action. So for example, in the first step, I want to go to the color red on my second RGB channel, which I have here because it's channel 2. Then in the second step, I also want to go to a certain color. And now here in this case, I want to go to the color blue. And then in the last step, I again want to start at step number 1, so to create a loop. And here I go to the action start loop and then at step 1. So what you just saw is that here we have multiple different actions that we can use within the sequence. So for example, we can send a scene number onto our KNX number, onto our KNX system within this sequence. We can also use a brightness for our dimming channels that we have. But here in this case, I only want to stick to this color here. And with that being set up, I can now also configure a fade time and then a wait time between those 2 steps. So for example, 5 seconds. Here also 5-second fade time, and then here the loop also should start after 5 seconds. So this is really something that you just have to play around with to create basically your own sequences or your own effects. So with that being set up, I can go into the group objects, and here we can see that we have a new object sequence on or off, which I quickly hook up to a group address so that we can test it. So now here you can see I will enable this sequence here now, write the value on, and what we can see is that the light now goes to red, or the spotlight, and then changes to the color blue, and then again it starts the loop and goes to the color red. And that's basically how this sequence now works. Now if I disable or send the value off, the sequence will simply stop at the current step and just stays at this color. And so these are basically all the settings that we have when we want to use the DMX Gateway as a master. Now one thing that I still want to show you is how you can use the DMX Gateway as a slave. So here I have a little DMX control panel, and with that I want to use it, for example, to control my KNX lights. And so therefore I have to change the configuration. So what I need to do is that I need to go into the parameters, and now instead of using the gateway as a master, I want to use it as a slave. And so then each of these monitoring channels can be mapped to one DMX address, but we also have a specific mode where we can use one monitoring channel for our RGB value, and then the monitoring channel reacts to 3 DMX addresses. And so here in my case I want to react to the RGB value and to the dimming value, and therefore I need 2 monitoring channels. The first one I can set up to RGB value, and the second one I can leave to dimming value. And then it's pretty straightforward. We simply have to set up the DMX addresses. So 1, 2, 3, and here for the dimming I have it on the address 4. And then what we need to do is that here within the send state we need to configure when the values should be sent to KNX. Because remember, DMX is a pretty fast protocol, and therefore you should be really careful on what you set up here. If you set it to unchange, what you definitely should do is that you go to the general settings and configure the telegram rate for KNX. Because otherwise your KNX system will be flooded with KNX telegrams by the DMX gateway. So with that set up, I can check my group objects, and here we can see we have a RGB object and dimming value object, and for each we also get an on-off object. I will quickly connect them to group addresses and download everything, and then we can see how it works. So now with that being connected, I can start to use the control panel and for example turn on the red color, and here we can see that we get the telegrams here onto the KNX bus. So here we have the color red now. Now if I go ahead and also do it with the blue slider, we can see that it moves up, and last but not least also the green slider. Now what we also see is that if I head over into the diagnostics, that we get a lot of KNX telegrams, and this is what I meant with if you have set it to unchanged, then definitely check the telegram limitation here in the general settings. Then last but not least, I also have it for the dimming value. So here the 4th slider on my control panel. If I move it up, we can see that we get also here the telegrams on the bus. Yeah, and that's basically how you can use the DMX gateway also as a slave to get messages from DMX onto your KNX system. So that's it for this video about the Weinzierl KNX DMX Gateway 544. If you have any questions left, then feel free to use the comment section down below.